second it's getting more natural.
So how's everyone? You were absent last class? Right? Exam. Did it go well? So where were we? Human eye structure completed. Eye structure completed.
Yes, sir.
And what about eye defects?
Yes, sir. But what defect is of myopia?
We did the ray diagram for eye defects.
Yes, sir. Yes.
Both?
Myopic and hypermetropic.
Both we have done. Okay. I think we did just one or both. We did only for myopia, I guess.
Yes, myopia.
है ना? Hypermetropia करना है. So what is the reason for myopia?
Elongation of eyeball.
Yes. So when you look at far object, it's not visible. Near object is visible. So far object when you see, the image forms in front of retina.
Yes.
So that is why you are saying eyeball is elongated. And or excessive curvature of the eye lens. Now let us cover the images for hypermetropic eye. Hypermetropic. It is also called as long-sightedness. It's one word, long-sightedness. There's one long-sightedness. So, in long-sightedness, which sight is defective? Which vision? Near vision or far vision? So near vision is defective, right? So the near point is not at 25 cm. This is the near vision. But the near vision is more here.
So the image is formed behind the retina, right?
Where?
In hypermetropic.
Yes. Because when it is behind the retina, when you keep the object at 25 cm. Okay. So let's open the diagrams. Near point of a hypermetropic eye. This image is near point of For a normal eye, near point will be here. And what is the symbol used for it? N dash. So this is N. This is N dash. Okay. So if you try to keep the object here, see what happens. So this is the eye lens. So it is N dash. In this case, the image forms
Behind the retina.
retina. Okay, so what you are supposed to do then? How will you correct it?
Convex lens.
Convex, because you have to converge more. Right? So when you converge it more, then somewhere on the retina it will fall. So this is, what is the title for this?
So the power of convex lens is positive, right? For
Yes.
And for concave lens, it's negative.
Negative, yeah. Focal length sign.
Yeah.
Okay, so now this is hypermetropic eye. Meaning you can't see near objects clearly. So if you want to see the near object clearly, what correction you should do? You should make use of convex lens because I need to converge it a little bit so that the virtual image will form at the faulty near point. Okay? When the image is formed at the faulty near point, that's when the image will actually be pulled back to retina. So this is correction for hypermetropic eye. So this is slightly tricky to draw this diagram. So let's keep the convex lens here first. The object is placed at 25 centimeters and dash. Now we have convex lens. So it will only gently okay. So then now it is. So where will it go now? I don't know whether I'm doing it right or yeah, it is right. So this one, the one which has slightly bent, but it is still diverging. Even after going through the lens, it is not converged like this. Okay, the power of lens is selected so that it is slightly converged, slightly. So it is still diverging, it's not parallel. So in the book also the diagram is not very clear. Instead of going straight, it will come somewhere here. Slight convergence. So now when you pull it back, okay. So the virtual image of this object, the real object, is obtained at the faulty near point of the eye. Now this eye will be able to see. Because whenever the object is here, the image forms at retina. So this is the correction. ठीक है? तो ये थोड़ा सा प्रैक्टिस करना बिकॉज बुक में वो रे सब सीधा ही दिख रहा है. Even after the lens it's going straight, it's not going straight. थोड़ा सा converge हुआ है, but it is still the output of the lens is still diverging. Only then you can pull it back. Okay? वैसा. So the regions, what are the regions for hypermetropia?
Flattening of island.
So one is long focal length, yeah? So large focal length, large focal length. Of islands. 2. Flattening of eyeball. मतलब eyeball is supposed to be spherical, लेकिन वो कैसा हो गया, पिचक गया. WWF.
WWC.
E.
लास्ट में इसका अपने आप ही बोला था.
तो है क्या? WWF भी है ना?
नहीं पहले WWF था मेरे मम्मी.
भाई हमारे टाइम पे WWF और अभी E हो. So E is I think scripted. WWF was raw power. So उसमें you will get flattened eyeball. यहाँ पे नहीं flat होगा. Have you seen that Arnold Schwarzenegger's movie? What is that? नाम नहीं भूल गया. उसमें वो रोबोट रहता है, ह्यूमनॉइड, टर्मिनेटर 2. उसमें उसका आई कैसा दिखता है? Whatever was made in that movie is now today becoming a reality, right? We have pilotless plane, and we have drone. सब कुछ हो रहा है remotely. The idea of artificial intelligence was like it is around since 50 years plus. आज का नहीं है. Because now it is taking shape, action में आ रहा है. Okay, next is refraction of, okay, presbyopia, some more defect, presbyopia and cataract. So far, how many defects you have covered?
2.
Myopia and
Hypermetropia.
BY. Biology is BIO and myopia is BYOPIA. Okay. So this is another defect. इसमें क्या होगा?
Associated with age.
हाँ?
Defect is associated with age.
Yes. So what with age? ये जो ciliary muscle है ना? So whether the object is far away or nearby, the image is always obtained on retina. So who controls that? The action of ciliary muscle on the lens, the crystalline lens, which is a flexible lens. So what this ciliary muscle does is, when the object comes near, it squeezes it, it contracts, so the lens becomes thick. So power increases, lens becomes thick, curvature increases, focal length gets shortened. So the image is on retina. When the object goes far away, then the muscle relaxes, lens becomes thin, and the power reduces, meaning the focal length increases. So irrespective of whether the object is far away or near, the image is always obtained on retina due to the action of ciliary muscles on the lens. So with age, this muscle loses its strength. So the contraction and relaxation of the lens is affected. So we don't get sharp focused image because either the image forms behind the retina or front of the retina. So presbyopia में both defect could happen.
Yes.
Okay? So then how do you correct presbyopia? You have to go for bifocal lens. Means the lens is having both. So let us say you have a eye with presbyopia. Then how the lens is? You must have seen. Like in old lenses, you must have seen that the two lenses are clearly visible. So either there is a demarcation like this. So the upper part is concave lens, the lower is convex. Lower is convex. Or sometimes instead of horizontal partition, you could see a round lens. If you have any old person in your house, grandpa, grandma, कहीं पे मिल सकता है bifocal?
No.
Yeah, these girls are being naughty. But now, so it was aesthetically not looking good. So now we have what? Progressive lens. So it progresses, right? So like I have a progressive lens. So bottom portion is convex and upper is concave. But the boundary is now not clearly visible. But then you have to train your eyes. If you are using progressive lens, so 10-20 days the eye training is required to get adjusted to this lens. Otherwise you walk like a drunken man. Okay, you feel the floor uneven till the eye gets adjusted. Okay, so either it will be horizontal line or this round to basically separate the two lenses. Is that clear? So when the far vision is affected, you require a diverging lens. वो ऊपर है, सीधे देखता है, far distance देखने के लिए. And to read something nearby, you see convex lens. वो नीचे के watch. ठीक है? Is that clear? So correction is by corrected using a bifocal lens. Next is cataract. What is the spelling here? Cataract. Now what is cataract? So this eye lens, this turns milky. Milky or opaque with age. Okay, sometimes with old age, not only the ciliary muscles become weak, the lens also becomes hard. Okay, it loses flexibility. And in case of cataract, lens becomes milky. So then what about the vision then? Blurred or no vision? Right? If it is translucent, you will hardly see anything clearly. Okay. So the only option is to do surgery, get the lens replaced with artificial lens. Okay, so that operation is called cataract. So nowadays it has become very easy to do this exercise. Everything can be completed. On one eye, it can be completed in 2-3 hours. So this is corrected through surgery. Corrected by surgical intervention, as they. So what do? They will remove the cornea. What will they do? They will remove the cornea. They will flip it like this. Then break the lens, turn it into powdered form, and with the help of syringe, suck it out. So then inject another lens, silicone lens. Cool, isn't it? So the patient is under anesthesia when this is taking place, so it's okay. बिल्कुल आँख पे मारेंगे और क्या करें? जब दांत निकालते हैं तो दांत पे मारते हैं, कहाँ मारते हैं? Local anesthesia, no? So it's on the gums. Obviously near. They will numb the place, and you will be conscious, but you won't come to know anything. chilling. All right. Generally, the doctor who operates so many patients, when he himself has to go through operations, it's like when you drive your own thing, and when you have to sit next to the novice driver, it's something like that. Okay, trust your doctor. Okay. So, any questions here? We are done with ID facts and correction. Next, we'll start with refraction of light through a prism. So, everybody understood what is bifocal? A lens that consists of both concave and convex. All right. In your new book, do you have this topic?
Yes.
Reflection of light through a prism. So, what is a prism? Prism is a transparent medium with 5 surfaces. Okay, out of which 3 are rectangular surface and 2 are triangular. Okay, so the prism appears like this. So, if you name this as ABC, DEF. So the triangular surfaces are triangular. So it has 2 triangular surfaces. What are they? ABC and DEF. And it has 3 rectangular surfaces. What are they? ADEB. Then you have ADFC. And you have BEFC. Okay. So a prism has a triangular cross section, right? So this is the base of the prism. So these 2 surfaces are called refracting surface, means light enters from one side, ADEB side, and it comes out from ADFC. Now this is a different refracting medium. It's not like rectangular glass slab. So on the rectangular glass slab, both the surfaces on the incident side and on the emergent side are parallel to each other. Here the surfaces are inclined. They are not parallel. So now we'll see what difference takes place. Okay. So to draw the ray diagram, we only draw the triangular face, the cross section. We don't have to draw the whole prism. Okay. So to draw the refraction, just draw the triangular surface. So ABC. And mark the midpoint on both the surfaces. So from the base of the prism, a line through the base of the prism, let us draw the incident ray like this. Okay, this is your incident ray. So this is the point of incidence. So you have to draw the normal. To be able to draw the refracted ray, you have to draw the normal. And this is the incident monochromatic ray. Monochromatic ray. Okay. What is monochromatic?
Single color.
Single color. Okay. So then, what is its direction? Original direction? It was traveling in this direction. But what happens once it enters the glass prism? It should bend towards normal, like this. Correct? It is a denser medium. So when it is entering from rarer to denser, it will slow down. It will bend towards normal. It becomes like this. Again, draw the normal at this point of incidence. So now it will go away from the normal. So what do you observe? When the ray enters the prism, it bends towards base of the prism. And when it comes out again, it bends towards base of prism. So it bends twice. Okay. So now label it. Let's call this as P, Q,
RS.
R and S. Okay. So this is angle of incidence. This is your angle of emergence. This will be angle of diffraction. We call it R1, R2. And when you, so this is the final angle of, so this is the angle of deviation between the emergent ray and incident ray. Okay? So it bends twice, one inside the prism and one outside the prism. Two refraction from two surfaces. One bending towards the normal, the other bending away from the normal. So in case of prism, you are getting a angle of deviation. Was it present in case of rectangular glass slab? No. What was present there? Lateral shift. So here there is deviation. Over there was lateral shift. Okay, that's the difference. So you can write down this as O. Right. MM dash. This is O and this is T. So quickly write down what do we have? PQ is incident ray. QR is refracted ray. RS is also refracted ray, but it is emergent. It's called emergent. So this is all about the rays. Then we have normal. So MM dash normal at base AB. So prism has two faces, AB and AC. This is the base. Then you have N dash. Normal at base AC. Then let's write down the angles. So angle में the angle which are significant are angle R. This is angle of incidence. And E is angle of emergence. Then you have A is angle of prism. This is the angle of prism. Okay. Then you have delta. Angle of deviation. So angle of deviation is basically the angle between the incident ray and the final emergent ray. Incident ray direction and final emergent direction. That angle. Okay. Now, do you have anything else? Okay. R1 and R2 are angles of angle of refraction. At Q and R. Okay, Q and R are point of incidence. Okay. So generally you will be asked to draw the diagram. Okay. So, draw the diagram for refraction of light through prism. So you have to just draw the labeled diagram and explain all this. So next we'll see what happens if we replace this with white light. Instead of monochromatic, we replace it with white light. So everybody understood what is prism? A transparent medium bound by white surfaces. जिसमें दो triangular और तीन rectangular. Okay, two triangular and three rectangular, just like this. So anybody needs any clarification? Very easy to draw this diagram. First we'll draw the prism, then mark the midpoints on AB and AC. Then from the base, okay, draw the incident ray. And this also bring it to the base. In between drawing the midpoints. Then draw the normal, extend the incident ray, backward extend the emergent ray, and just do the level. Okay. Next, we are going to study about dispersion of light. Now tell me what will happen when a white light is made to pass through a prism. So white light from the source, we are passing it through a cardboard with a thin hole, so that a fine beam of light is going. Okay, fine beam. Same here. The source of light is somewhere here. This is the source of light, and some slit, as it is called a slit, because here the light is traveling in all directions. You want a focused beam of light to travel straight. Okay, this is called slit. Slit is a small opening through which the rays. Now what happens here? Tell me. Why?
The speed of light is of color is different in the example.
Yes, we saw in the last discussion that the refraction of light, refractive index will be different for different colors. What is the refractive index for? Relation with refractive index of wavelength? There is inverse relation. Isn't it? Because what is refractive index? It is equal to V1 by V2. So for absolute refractive index, it will be
C by V2.
C by V2. Right? Now, if it was a monochromatic, let's say single color light, single color, what it will be? F lambda divided by F lambda in the second medium. This is the first medium. F remains same, no? In both the mediums. So what will you get? ठीक है? So C तो चलो ठीक है, इसको तुम V1 by V2 ले करो, तो क्या आ गया हमारा? So mu is therefore equal to lambda 1 by lambda 2. So lambda 2 is in the medium and lambda 1 is air. तो अगर air होगा तो lambda 1 will be constant for all the colors because all the colors travel with same speed in vacuum, but they travel with different speeds inside. So now the lambda inside the medium will be different for every color. ये तो constant है. So mu is equal to this exercise we have already done. Lambda in the medium. ठीक है? So refractive index will be more for smaller wavelength. So what is the wavelength? This is 4,000 angstrom. And this is 8,000 angstrom. Maximum is for red color. So which color will bend more? Violet or red?
Violet.
Violet. जिसका wavelength कम होगा, उसके लिए refractive index will be more. Deviation will be more for violet color. So जो इसके अंदर violet वाला color है वो नीचे आ जाएगा, और red वाला थोड़ा सा green. और ये इसका original है. यहाँ पे जब तुम बाहर निकलोगे तो और नीचे जाएंगे. So we keep a screen here. So what will you get? You will get a band of colors. So V, I, B, G, Y, O, R. ऐसा band of colors मिल जाएगा. ठीक है? So you get band of color between these two. So this is red on top, violet at bottom. ठीक है? And all the 5 colors. So this is called dispersion. Splitting of white light into its component colors is called dispersion. So where is the angle of deviation more for which color?
Violet.
Violet. Because if you extend it backward, यहाँ जाना है. Okay. So this is the deviation for red color. And this is the deviation for
Violet.
Got it? So violet color deviation is more than red color. What about speed?
Speed
Red.
is more than violet.
Red.
So VR is more than the violet. What about deviation?
Violet.
like this it is. What about wavelength?
Red wavelength is more.
Yes, this is how it is. That's it. What about refractive index then?
The violet refractive index is greater.
Yes. So deviation and refractive index go together. So there are many logical questions basis these relations. So in numerical it is ND. MCQs में आता है ये relation based questions. All right. Okay. So where is dispersion taking place at this point? On face AB. So what is taking place here? Refraction and dispersion. And this band of colors is called spectrum of white light. So on face AB, refraction and dispersion is taking place. What is taking place on face AC?
Yes, you see.
Is dispersion taking place here?
No.
No, only refraction, like that. Now these are individual colors. They are only suffering now refraction. So on face AC, refraction only. On face AB. Okay? So hope you have understood it. So the question, are these colors component of white light or is prism adding it? These colors are part of white light or is prism adding it? Part of white light. So prism is not adding it, right? So otherwise it would have shown a spectrum here also if prism was added, or it should have further added some colors here. But that's not the case. To verify this.
So then how is rainbow formed? Like it's formed by the raindrops, right?
So raindrops act as prism.
Prism.
They are the dispersion medium in the atmosphere. Yeah. So the constellation of so many rainbows form this thing. Okay. So rainbow formation is there. We'll see how this. So there is something called as recombination of So when you keep two identical prism side by side, with the second prism identical but inverted. So what was the rule of refraction? This is violet, this is red. Now what will happen? Okay. So it has gone down. Has it gone down? It will slightly show it to go down. Okay. And this also should go a little down. So they're not parallel, right? Now, what happens? Whenever light enters the prism, it turns towards the base. What is the base in this case? Okay, light bend towards BC. So instead of going straight, it will bend towards BC. This also will bend now. This is violet, so it will deviate more. Red will bend less, violet will bend more. So finally it joins.
So the diagram suggests.
And
So the diagram kind of suggests the opposite. Red is bending more than violet.
where is red bending more?
When we are
Sorry, उल्टा लिख दिया मैंने. ये red है ना यार. This is red. This is violet. You cannot do this. Now, वो विप्योर के चक्कर में होता है, लेकिन the spectrum is विप्योर is bottom up. So red has to be on top. It will bend less. Okay, here also red will bend less only in both cases. So it was white light. And again, all these split color is recombined back to white light. So this demonstrates that all this splitting of color, these color are component colors of white light. Prism does not add any color from its side. Otherwise, it should have been more colors here. Okay, that's what it is. Demonstrates. That prism does not add color. Are component of white. Yeah, hope the concept is clear. So now we'll see various applications. The concept is covered now. Okay, we'll see the applications of all this. So first application is formation of rainbow.
Sir, does the splitting of colors also happen in rectangular glass slab?
But in rectangular glass slab, this happens. The splitting happens in between.
Oh,
And then, so this is also when you join these two prisms, what happens?
yeah, you get a rectangular surface.
You get a parallel surface. So what you'll get is slightly lateral shift. It is here. So these two lights will be parallel. When you remove the gap, it is a rectangular glass level, two parallel surfaces. So what will happen? It will lateral shift. So white. In between there is a split. Okay, that's what it is. Does that answer your question? So there is a splitting because obviously white light will get split, but when it emerges out, it is getting recombined again. That's all. You can draw the ray diagram and check for yourself. When the emergent rays comes out, it is bending. And therefore, very soon it will combine. So you get a white light. Okay, formation of rainbow. Wherever you feel you require extra explanation or you have question, do ask. Rainbow. So, how many of you have seen actual rainbow? Okay. So how did you experience? What was happening? You require sunlight, and you also require rain. So if you're observing rainbow here, the sun should be behind the observer, and rain should be in front of the observer. So at a certain position of sun, so what is in front of you? A water drop. For simplicity, let's take one water drop. Let's say the sun rays entering the water drop. Okay. One sun ray. So what is the normal? Is the normal radius? So it is entering from rarer to denser. So what will happen? Red and violet. Correct? Now there will be a reflection inside because every surface there is, it's not 100% transmission. Some part is reflected also. Understand? So the reflected ray so this is how it is. Then what will happen? But anyway, so then what do you have? This is another copy. What will happen? Normal pen, it was SL. Okay. So if there is any observer on the ground, let us say you have an observer on the ground. क्या दिखेगा उसको? ऐसे बहुत, there are so many drops. So the band of color, you have the upper color is red, bottom color is violet, and all the colors in between. Okay, so in the sky, you will see rainbow. Is that clear?
Yes.
So how the rainbow is forming? What is the sequence? Sun conditions for rainbow. Sun behind observer. Rain in front of observer. Okay. So what is taking place here? Refraction and dispersion. So and dispersion. Oh. As it enters the raindrop. Okay. So then you have internal reflection. This is the sequence. So internal reflection from the behind surface of the water drop. And third में क्या होता है? Reflection. Of dispersed Okay. So when it is combined across the entire water drops, you get a continuous rainbow. And how will it see? Will form. So from where you are standing at the apex of the cone. So the rainbow appears circular, semicircular on the horizon. But you may see full circular rainbow if you are flying in a plane. Okay? So, but from the horizon you will see only half. So that's about rainbow formation. So the diagram in the book given is like the entire rays are getting combined. Okay, so वो तो white हो जाएगा, वो वैसा नहीं है. It is only a schematic diagram. This is more near real diagram. Okay. Is the logic understood?
Yes.
So next we have atmospheric refraction. So we will understand it in the next class, and that is responsible for twinkling of stars. Okay? Because what happens is the position of the star shifts up and down. Okay? Because of atmospheric refraction. Whenever the light rays are traveling from star in the atmosphere, it suffers bending. Because from space to atmosphere, it enters a denser medium. So its position shifts. But atmosphere itself is dynamic medium. It is not fixed like prism or glass. So due to difference in temperature, the density of the atmospheric air at different layers of atmosphere changes. It's not fixed in time, it varies. And therefore the position of the star shifts up and down. But our eyesight is gazed in one direction. So let's say you are seeing the star in its last position and suddenly it goes up. So for you it disappears. And then again it comes down. So it reappears. This constant appearance and disappearance of stars gives you the impression of twinkling. So it is due to atmospheric refraction.